Hi, this is James Cook of the University of Maine at Augusta, and I am recording this video in order to demonstrate how to use R in a particular environment called RStudio in order to write social network information, to plot social network information, and to analyze social network characteristics using the package called Igraph. That's a lot of parameters for one sentence, right? But what it boils down to is that there is a computer program called R, which stands for research and has been written by researchers, which is overall free, although you can pay for some bells and whistles, that you can use in order to work with social network information. Now, in order to do that, you're going to need to work with a package called Igraph, and it allows you to enter network data, to create pictures called graphs of networks, and to analyze social networks for their structural properties. And that's what we're going to do today. I'm going to be working with a version of R called RStudio Cloud, which is up in the cloud somewhere on the internet, on a computer there. An advantage of that is that R will take care of all the needs your computer program might have in terms of memory, in terms of hardware, things like that. So you could run it from any computer. And what you'll see here, therefore, is a little particular to RStudio Cloud, but is something that will work in general for RStudio as well. Now, RStudio is something that consists of 4 windows. One of the windows is console, in which R talks back to you. One of them is the environment, which shows you all the variables and data sets that you have. One is a files and plots and packages area that allows you to look at input and output of other kinds. And then the 4th is called the script window, and that's where you talk to R and tell it what you want. We're going to set up a new script, a new file under File, and then hit RScript. And that's our window of creation. It's where we take commands and ideas that we have, and we express them to the computer that is running RStudio. So one of the first things we'll want to do is install a particular addition to RStudio called Igraph. And we can do that by going to Tools and Install Packages. And then it'll allow you to choose a place, like some repository, to somewhere out on the internet to install packages from. And we're going to want to type in Igraph under Packages and then Install. You'll want to click Install Dependencies because sometimes packages like Igraph depend on other packages that have been built beforehand. And so by clicking Install Dependencies, you'll be sure that you'll install all the little sub packages that are important too. So I'm going to hit Install. And it's going to ask if I want to reload it because I've already installed Igraph, but we're doing it again. It'll take a good minute or possibly 2 in order to do that. And when that's happening, you'll notice that down in the console window, a stop sign appeared. And that stop sign appeared because it was telling you that it was thinking and working on something, so hold off and don't do anything. Okay, but now it says it's there, it's installed, and we can look in packages and we can look at a whole list of possible packages that are out there, and it looks like Igraph has been installed, and it will even tell me which version has been installed, in this case 1.2.6. That's nice. But what I want to do now is I want to work with Igraph. And the way I work with Igraph or any other package is to call it. And I don't know why it's not called a package command, because these things are called packages. But no, it's called the library command because, you know, we need to have some complication in our lives. So the command library loads a package. Now you notice when I enter library and then I put in a parenthesis indicating, hey, I'm gonna name a package, it gives me some alternatives here. And so I'll select Igraph. I could have just typed in Igraph and then an end parenthesis. That's the end of our first line. I'll hit return and move to a second line now. And there are a good number of ways to enter network data, but one of the simplest is by thinking through something called an edge list. And so I'm going to name a network, and I'm going to name it really inspirationally my first network. And I'm using underscores between the words because there's a rule that any object, anything that you're defining in R needs to all be one word. So if you have 3 words that you want to make one word, but you can still read it, use those underscores. It works. And then we're going to use an arrow. And the arrow is pointing to my first network, but then there's something on the other side, and it says, well, what is this thing called my first network? And you're going to tell the computer what that is. And what it is going to be is a network object. We're going to call it a graph. And there are a lot of ways that you could write out what this graph is, but we're going to create an edge list. And so one of the things that you'll notice in R when you write R is that you'll write a command like graph, but then it will have options. And you can see R is very kindly reminding me what those options are. And the first thing I need to do is to type in edges. And then I have to, well, say, what are the edges equal to? And there's just a rule here. If you have a list of things, you need to put a C in front, okay? And then a list of what? Well, we're going to create another parenthesis in there, and we're going to put in quotes to let the computer know that this is just a text label that we're working with, the names of the nodes that are connected to one another, excuse me, in a tie. So I'm just going to start writing some down. Let's call our first node Alice, okay? And now Alice is going to be connected to someone. Who? Alice is going to be connected to Sam, who is our second node, okay? Now that's a network. It's a network of 2 nodes connected with 1 tie, but that's a little boring. Let's jazz it up a little bit. That is an edge right there, right? Where an edge is another word for a tie, and a tie is between 2 nodes. But if we want to include another, we're going to put outside the quotes another comma, and then let's put in another pair. Maybe Sam and Sam is connected to David. Okay, and then I would put another comma, and I'm putting a space in between the pairs so I can see how they're paired up. It's a little bit easier that way. And then David is going to be tied to, let's see, Edgar. I always liked that. Oh, now you notice I made a little mistake here. I put the comma inside the quotation marks. Bad move, that'll get you an error. Always something to look for. The comma goes outside the quotation marks, okay? And then Edgar here is going to need an end quote. And then, oh, who should Edgar be tied to? Let's make this a little bit more interesting. Let's create some central people. Edgar is also going to be tied to Sam, just like David and just like Alice. And finally, Sam. Let's have Sam be connected to someone that nobody else is connected to, like Inez. That's a great name. Okay, and then I'm going to end that list by putting in 1 parenthesis here. And then I notice there's another parenthesis right there, right, by edges. So I'm going to make sure that that is also included, okay, to finally finish off those parentheses. On every line, always make sure you finish off your parentheses, because that tells R this part is done. So there is my first network. Now I could simply then call it up It is now an object, and if you just type in the name of an object by itself, it'll print something out. I could do that. Let's see what happens when I do. And we're going to run this. We're going to run all. Oh, great. Okay, so now it's showing me down in the console section. Now that I've run this, after I have the command my first network, it says, oh, it's an Igraph object, and it has edges. And here they are. Alice is apparently tied in a direction to Sam. Sam is tied in a direction to David. David is tied in a direction to Edgar. Edgar is tied in a direction to Sam. And Sam is tied in a direction to Inez. Why are they tied with direction? Because there is an assumption here in this graph command that if you don't name your network otherwise or describe it otherwise, then it's going to assume that it's a directed network, one with direction. If I want to say, hey, this is not a network with direction. These are people who play tennis together, right? And there's no like Alice plays tennis with Sam, but Sam doesn't play tennis with Alice. That just doesn't make sense. So I'm going to say, let's make this undirected. And I can do that by adding in, after the edges part, the command, the sub command, that directed equals false. Now, I could say directed equals true to make it a directed network, but if I want it to be an undirected network, I'll just say false. And now when I run this program, and I'm going to clear the console with, I think, Control L. Yeah, it always does that. Nice to clear it so you can make sure that any errors are from this run, and any results are from this run too. I'm going to go to Code, Run Region, Run All again. And now notice that instead of a dash and then an arrow sign pointing in the direction of the tie, there's no direction anymore. Alice is tied to Sam. No direction, just two dashes indicating the tie. Sam is tied to David, David to Edgar, Sam to Inez. Great. This is my first network. It's in Igraph. It's really painfully easy. What more could there be, you ask? Well, we could create a picture of that called a network graph. And to do that, we simply type in plot. And then, as always, there's parentheses after your command that are specifying the options. What's the big option here? The most important option here is my first network, which is the object, this network object that I defined myself right here. One of the nice things about RStudio Cloud is that when I highlight one item, it'll show me where the other ones are. So in a little box, so I can see how they relate. Okay, so shall I run it? Yes, I shall. And then let's see what happens. Okay, so I'm going to run all, and then boom. You'll notice over here that I have a nice, neat plot in which I have Inez, Alice, Sam, David, and Edgar. What could be simpler? Not much. That's a lovely plot, and if I want to, I can export it. I can do that by, I believe, right-clicking, and then I could save the image. I could also copy the image, and then I could paste it into, say, a word processing program if I were writing up some form of I don't know, an academic article, or I don't know, some homework that had to do with social networks, that sort of thing. And that's lovely. Now, that's not the only way to get network data in. What if you're working with, say, a pre-existing network? And I'll show you one here. This is a network edge list, right? And these are different names. Louise is tied to David, Dave to Charlie, Charlie to Adam, Adam to David, etc., etc. Felicia to David. Let's put Inez in there as well. You know, and Inez could be tied to Grace, and Grace is tied to Louise, and Louise is tied to Felicia. So, and did I say Inez again is tied to Sarah? Okay, so I could keep going, and the point here isn't the number of ties that I have. It's that this project could keep going and going and going. Or you might have already collected network data and it has, 1,000 edges. What you don't want to have to do is go into RStudio Cloud and have to type them all out again, especially in a laborious kind of effort where you have to remember to put the quotes in exactly the right place and the commas in exactly the right place to make the whole thing work. It would be a visual mess and it would be so error prone. So let's think about another way to enter network data into Igraph, and that is by let's create a second object called my second network. And what are we going to have that equal to? In this case, right, we're going to have it be a processed version of this CSV file, network edge list, right? Okay, so in order to do that, I'm going to bring in my data from that CSV file. And the way to do that in RStudio Cloud and RStudio, if you have a version sitting on your home computer, is through the read.csv command. And then, of course, we'll always put in parentheses. And we're going to use the version of the command called file.choose, where you can go and you can get that lovely CSV file and just choose it from your computer. In this case, right, there's an option that we need to be careful about, because usually when R loads in a CSV file, it's looking for something called headers, which is a first row of data that is giving the titles to each column. But we don't have that here. So we're going to make sure that we're going to type in the subcommand header equals false, which means there's no header in this file. And then my second network is going to be a bit of gobbledygook, but it is basically taking that data and it is identifying it for R using graph.data.frame. And as you can see here, it describes with a little bit of help, this function creates an Igraph graph from 1 or 2 data frames containing the edge list. Great. So we're going to do that. And what's it going to work with? What is that data? It is my data, which I named in the line above. And then let's decide, is this a directed or undirected network? Well, our first network was undirected, so let's make this, just to be explicit, directed equals true. Okay, and then we could say, hey, let's take a look at my second network, just to provide those edges. And then let's plot my second network. Okay, so I'm going to clear out the console, and I'm even going to clear out the plots so that we can, this is something you can do with this, a little broom icon here, okay? So broom icons on the right to clear out those, and over here on the left with the console, Control L to clear the console out. You don't need to do that last bit, but it's kind of nice and neat. Then I'm going to go down and I'm going to run this code. Code run region, run all. And I'm running into a bit of error, right? This is a particularity of RStudio Cloud. Like RStudio and R, it's working on a computer and it's trying to access files on a computer. But in the case of RStudio Cloud, it's not my computer. Instead, it's an imaginary computer that is sitting on the cloud. And what it's telling me here is that, there's nothing to read, is there? Okay. So what I'm going to need to do is upload from my computer using this upload button, and I'll go to File, Upload. I will find that a file called Network Edge List, and then I'll click OK, and it will upload it into that computer, the virtual computer right here with the files. And now it's available. Okay. I also noticed that there's something missing here in my file choose, and that is a pair of parentheses. You have to put those in after file choose. You could have options in there, but if you just have a beginning parenthesis and an end parenthesis, it means no options. I don't want any options there. I just want to choose a file. So let's clear this out again, the console, and let's run it again. Having errors and problems like this is a natural part of the ebb and flow of writing a program. You should be ready for that. But when we do that now, wow, it's going to ask me to choose a file from this local pretend computer environment. And I have my network edge list here. And so I'm going to open it. Oh, super. Oh, that's great. So if we go look through the console here now notice there's a whole lot that I have to look through. If I want to make this a bigger window so I can see it all at once, I could click this larger window icon. And then if I wanted to make it smaller again, I could click that icon again, just make it bigger, make it smaller. It's always something you can do. Well, here it is. It's going through these commands, and it's reporting back to me what it sees. So it does all the work for plotting the first network. In fact, it then said, plot my first network. Okay, where is the first network? I see the second network here. Well, if you look under plots, when I click on that little tab, there's a little blue arrow now, and it's for previous plot. Cool. Okay, and then I can go use the right one to go to the next plot. So if there's more than one plot, you can access them in that way. Okay, so it's plotted the first network, and then it allowed me to read in the file, and then I said, well, tell me about this network. Always a good thing to do to make sure that the computer is working with what you think it's working with. And look at all those beautiful ties, some of which I just wrote into the spreadsheet a minute ago before I saved it. And then when I plot it, here it is. Ah, that's lovely. Now I want to see my script again. Here I am in my script. We've done a whole lot in less than a half an hour, and I've been going pretty slowly, which is fine, as you might want to do. But now let's say I want to do some analysis. For instance, I might want to calculate measures of centrality. Let's do it for the simpler of these two graphs, right? So let's take a look at one which is betweenness centrality, which we calculate with the command in Igraph for betweenness. What do we want it for? We want it for my first network. Whoops, I need to spell that correctly, 2 underscores. And then I have to tell it, because betweenness is calculated differently depending on whether it's a directed or undirected network. In this command, I need to indicate directed equals false, because it is. Let's make sure we said so. Yep, up at the top, it is not a directed network. Okay, and betweenness centrality is all about if there are paths that are the shortest paths between two nodes, any pair of nodes, it is another node in the middle of that. And if we look at all pairs of nodes in the network, which nodes are most often in the middle of those paths, in between everything. They're the conduits. That's important. Then we could measure closeness centrality with the command closeness. Again, my first network. And for this, it calculates the distance, which is the number of intervening ties between any one node and all other nodes, and adds them up for all the other nodes, and then takes 1 over that number, because that's calculating distance, farness. Closeness is the opposite of farness, so you do 1 over farness to equal closeness. And we don't need any options for that. Ooh, what fun. We could also look at the degree of my first network. And for this, the mode would be, let's do all, right? All the possible ones there, and we will, right? You could actually just do in degree or out degree, but here we have an undirected network, so we're just going to do mode equals all. Now let's calculate the edge density, right? It's the ratio of the number of edges and the number of possible edges, the number of ties and the number of possible ties. So edge density is the same as network density, and that is going to be for my first network. Okay, and then diameter, which is the longest distance in that network. Can you see what that longest distance is going to be? Right, you can in this simple one, but maybe not so much for a more complicated network. My first network. Okay, and then let's take a look at all the distances, a matrix in which every node has a relationship to every other node, except that instead of it being about a tie, it's about the distance between those two nodes. So you can get all the distances printed out at once. Really cool. And you do that, again, the first option is my first network. And again, this also has a mode that is indicating, and we're going to select all because this is an undirected network. It's important if you have a directed network with direction, right? Distance is determined. You have to follow the direction of the ties. So that's an important one to keep in mind as an option, because you could have all these other different modes, right? But we'll have mode equals all. And then, oh gosh, let's find, are there any clicks in there? And we use the command clicks, or some people pronounce it clicks, but looks like a click to me. My first network is the first option. And then here's an important option. This is the minimum size of a click in terms of the number of nodes it has. If you select minimum equals 2, then it will take any pair of nodes that are connected, because there's 2 nodes and they have a connection there, as satisfying a clique. Let's look for ones that are size 3 or bigger. And remember, a clique is a set of nodes where they're all tied to each other. Now, most people learn cut point as a command, okay, but or as a measurement. But here in Igraph, it's called articulation points, but it's synonymous. An articulation point or a cut point is a point, a node that if you remove it, takes what is one connected network, that is, every node can connect directly or indirectly to every other. There's a path from one to another. And the removal of that one node would cause the network to break into multiple pieces that are disconnected from one another, where the distance is like infinity. There's no way to get from one node to another. And, oh, right, we need the option, my first network. Okay. And then, you know, if you have a network that is already broken into pieces, it might be useful for you to be able to identify what those pieces are. They're called connected components of a network, the parts of a network where every node can get to every other node. So we could look at those components. My first network. Okay, so these are all commands that we can run that will not just create plots, but will run an analysis and allow us to understand a network better. And so when we do that, let's clear the console again and run it. What will we find? Well, first it's going to ask us to, because we forgot to take that second network option out. It is going to run that, so let's select that again so it can run that part. And now we have a whole lot of, we've got our plots. Okay. Here they're beautiful plots. You can change graphic elements of the plots, but we won't cover that today. And I'm going to expand my console so I can read the whole thing. And it's going to give me this lovely output. It's going to talk about betweenness, right? Let's pull up the correct plot. And it's going to give Sam the highest betweenness, and it's going to give every other node a betweenness of 0, because Sam is the only one that's in the middle of those connections from one node to another. Closeness, right? So we know that Sam has a closeness of 0.25. We can verify what that means by counting out. Sam to Alice is a distance of 1. Sam to Inez is a distance of 1, so that's 2. To David is 3. And to Edgar is 4. Okay, so that's a total distance of 4 to all the other nodes in the network, and 1 divided by 4 is 0.25. Sam is closest to all the other nodes as well. Again, this is really intuitive here. You might be able to calculate it by hand, but what if you had a bigger network? A lot harder. So we've got now the degree distribution here. Sam has a degree of 4, Alice has a degree of 1, David and Edgar should have a degree of 2, and again, Inez has one of 1. Okay, great. What about edge density? Yeah, it's 0.5. Good. It should be between 0 and 1 because it's a fraction where the number of actual ties is divided by the number of possible ties. In this case, we can count the number of actual ties. It's 1, 2, 3, 4, 5 because there are 5 lines in that graph. So 5 divided by what? Well, this is an undirected network, so we know that for an undirected network, the number of possible ties is n times n minus 1 divided by 2. And so n is the number of nodes, and there are 1, 2, 3, 4, 5, 5, and then 5 times 5 minus 1, which is 4. 5 times 4 is 20, and we have to divide that by 2. 20 divided by 2 is 10. 5 actual ties, 10 possible ties, edge density 0.5. Half of the ones that are there, that could be there, are there. What's the diameter of my first network? Well, it's the largest distance, and the largest distance here from any node to any other node is 2. How do we know that? Well, we can look at the distances matrix, and we can see that, for instance, from Alice to David or Alice to Edgar is a distance of 2. Same from for Inez to Alice, right? All of them going through Sam, which is why Sam has that betweenness centrality. It's a lovely matrix, right? And we know, of course, the distance from Sam to Sam is 0. The distance from Alice to Alice is 0. That's good to know. Links. There's just one, and it is Sam, David, and Edgar, right? Good. Okay, is there an articulation point? Yes, there is one articulation point. And again here, it is named as Sam. Sam's the one, you take Sam out, it blows that connected component up into multiple bits. And what connected components are there? Oh, look, here's one. Alice, Sam, David, Edgar, and Inez are members of one connected component, that first connected component. If there were more, you'd start to see a multi-row list. Wow, that's great. Really quickly, you're able to take this information and you're able to run a basic descriptive analysis that tells you what role different nodes play in a part of a network. You can do it for a small network like this, or you can do it for a larger network like this, where we start to not be able to see all the patterns as easily, or you can just as easily, with just as few lines of code, really not many lines of code at all, you can do this for a network that has 10,000 nodes, which becomes really important when you start to study in-person, in-situation, real-life networks that exist online, in social media, in various forms, in terms of links between websites to talk about another form of authorship online, or when you're looking at large bodies offline, say like congresses or interacting clubs in a university or something like that. Very simple, very easy to do. And now if you're a student of mine, it's your turn. And I'm really looking forward to seeing what you have to offer.